think so.
Yeah.
Oh yeah, now we're live.
Great. Oh, right on time, Mariam.
Yes.
Hello, Mariam.
Hi.
Hi.
Hello. Hi, Marco. Hi, Anastasia.
Hi. Good
Sorry,
morning.
some technical issues.
No problem. You're right on time. So yes, thank you everyone for joining. My name is Anastasia, and I'm part of the science team at Econometrics, and I'm together here with my colleague Mariam. And today we have a very special guest, Dr. Marco Sakai, with whom we would like to discuss about the spend-based emission factors.
Thank you very much.
Hi.
Thank you for having me.
Great.
Hi, everyone. Great to be here with you, and also with Anastasia and Marco. Looking forward to our discussion.
Great. Yes, just to give some background. So Marco, you're a lecturer at the University of York at the Department of Environment and Geography, and you're an ecological economist with more than 12 years of experience. And you were also involved as a research fellow in the Sustainability Research Institute at the University of Leeds. And you also worked at the Stockholm Environment Institute, and you also conducted macroeconomic analysis at the Mexican University of Finance, and you worked at the UN Conference on Trade and Development. Is everything correct?
Yeah, well, I worked in the Ministry of Finance in Mexico.
Yes, yeah.
Doing economic forecasts and macroeconomic analysis. But yeah, that's in very short terms what I have done. Yeah.
Great. Yes. And your research is mainly focusing on analyzing the links between the climate and resource consumption at the moment.
Yeah, so I am interested in the links between climate and the economy, and a lot of my research focuses on that.
Yeah.
Particularly in the area of emissions and carbon accounting.
Great. Yes, exactly. That's what we wanted today to talk to you about. And by the way, we have prepared quite some questions for Marco, but please, everyone who has joined us, do ask questions in the chat, and for sure we will find some time to address those. Great. So Marco, we wanted to discuss with you today the spend-based approach, because we see a lot of interest lately from the companies when it comes to understanding their scope 3 emissions, because the spend-based approach seems to be like an easy, or even better, easier approach to assess the emissions from supply chain, but it also has some limitations. And so we wanted to discuss maybe in the very beginning, just to try to understand how those spend-based emission factors are derived in the first place. And I know that spend-based emission factors are obtained from the so-called input-output tables. Maybe you can give us a very broad idea what it is. And let's say for non-professionals, someone outside academia and research, what is an input-output table, and how can those spend-based emission factors derived from?
So in very basic terms, you are correct that these emissions factors are calculated by using input-output tables for a number of countries. So what is an input-output table? An input-output table, I would say that it is a photograph. I mean, if you can think a little bit like that, it's a photograph of an economy, right? Of the structure of an economy. Now, in terms of being more specific, it is a table, right, that contains the same number of rows and the same number of columns. So in matrix algebra, you would call it a rectangular matrix, right? Where the columns represent the inputs and the rows outputs of different sectors that are included in an economy. So for example, if you look at the rows, it would tell you which sectors produce things for other sectors in the economy, right? So what is the output from one sector to other sectors? And the rows, they represent the input. So what are each sector receiving from other sectors in an economy? So in a sense, you have a very detailed description of all the interactions between different sectors that form an economic system. Apart from this rectangular matrix, you also have additional information related to final demand. So you have the final demand from households, the final demand from businesses, from government, as well as from the foreign market. So you also have exports and imports. Now, from an economic accounting approach, you know that all the spend or everything that is spent must be equal to everything that is received by some economic agent. So all the money that I receive as income, I'm going to be spending it, and that is an assumption in an input-output table. So you can account for something that we call gross domestic product, or GDP, everything that is produced in an economy, from an income or an expenditure approach, and that is also represented in an input-output table as additional columns and rows. So in very basic terms, that is an input-output table. So as I said at the beginning, it's basically a photograph of an economy at a certain moment in time. Now, input-output tables are published by the national offices of statistics of different countries, and since they require a lot of information, and they require a lot of information on the specific transactions between sectors and also about the expenditure from different economic agents, it takes time in order to compile and in order to produce these tables. So some countries publish them every 5 years. Other countries try to publish them more regularly. I think in the case of the UK, for some years now, they have been published annually. But still, there are many countries where it is difficult to get updated tables, and sometimes they update them every 10 years in some cases.
Yes. Great. So then input-output tables are mostly about economy.
It's mostly about the economy, yeah. So it's representation of the economy, right?
Yes. So how do we move from the economy to the spend-based emission factors? How can we?
Yes. Okay. So in addition to the economic transactions within an economy, you can also include what we call environmental extensions. Basically, every sector is responsible for a certain number of emissions. So every sector, when it is carrying out its activities, it generates emissions, right? So we also can attach or assign emissions to each sector depending on a number of assumptions. For example, the energy used by each of those sectors, or if, for example, in the case of minerals or metals or mining, we know that there are some emissions associated to that. So these environmental extensions, right, are added to the input-output table. In the case of CO2, we have available data for emissions for each of these sectors, and those are the ones that we are using in addition to the economic table in order to generate the emissions factors. Now, since these are emissions factors based on spend, we know that every time that an individual spends a certain amount of money in order to obtain a certain product from a specific sector, it is related to a certain amount of emissions, right?
Yeah. So it's a kind of top-down approach. So we start with
it is a top-down approach, yes. So this is the approach that is used in order to calculate the carbon footprint at a national scale, or at a scale also of an industry or a sector. But this is very top-down, right? It is very aggregated.
Great. Thank you so much for the explanation. Very informative. So one question, what are the most famous input-output tables? I mean, What are the most famous ones, and what are the differences between each in terms of strong and weak points about each one?
Okay, so there are several databases available. I think 12 years ago, 10 years ago, it was difficult to get information that was compiled for a number of countries together in the form of a global database. Now here I have to make a distinction between what is an input-output table for a single country and what is what we call a multi-regional input-output table, right? So an input-output table just describes a single country. A multi-regional table contains a lot of tables put together for different countries showing how their economies are linked, right? So now the sectors from one country are going to be receiving inputs from a lot of other sectors from other countries, right? And a specific sector in a specific country is going to be producing outputs for a lot of sectors along the supply chain to other countries. So in a sense, this photograph that I was talking about is not only about one country anymore. It is now a photograph of the economy of a region, right? Now, it can be a region or it can be the global economy. So we have some databases now that try to represent the global economy. So we have several of these databases. One of these databases, for example, is called the World Input-Output Database that compiles tables for, I think, 43 countries, I think, and 56 sectors. We have another one that is called IORA that was compiled, that this one has been compiled in Australia by Manfred Lenzen and his team. I think this one contains tables for something like 190 countries. There's another one that is Exio-based that contains tables for 44 countries, and I think 44 countries and 5 rest of the world regions, with something like 163 industries. There's another one that is called GTAP, the Global Trade Project. This one, I think, contains something like 121 countries. So we have a number of them. I think one of the most consistent ones, I think, in terms of being able to gather information that has been analyzed and has been curated in a way, in order to, maybe I can say that in order to produce more consistent figures, is the one that is published by the OECD. I think this one contains 66 countries and for the period from 1995 to 2018. And apart from that, I think that we have other efforts to produce other databases, but I would say that these are the most important ones. Now, I have to remind you that also nations produce these tables on a regular basis, right? So actually, I mean, you could, in a way, come and compile your own database if you could, by putting together different tables from different countries. So let me just adjust my audio because I think I'm losing.
Okay.
Just give me 1 second.
Yeah. So.
Hello, can you hear me? Yes.
Yes.
Okay, good.
Yep.
Great. Yeah.
Sorry. Let me know if you're understanding everything. If I'm giving good answers. If not, please let me know or send some comments there, some questions.
Just wanted to add. I mean, so in addition to region coverage, I mean, are there any big differences among these different IoTs or not?
Yeah, so there are big differences. IORA, I think, is the one that has a larger coverage with something like 190 countries. Most of the others, I think, are covering only 43, 44, 60 countries. And then the rest of the countries in the world are aggregated into a single region, which is called rest of the world.
Yeah.
Okay.
Great. So this it seems to be like a great research tool, those multi-regional input-output tables, but we're also interested, are they also used outside the academia? I think you partially have answered to this question, because you said that the governments actually compile these input-output tables and also renew them on a yearly basis or couple of years basis. And yeah, so is there some other use, or is it solely used only in academia?
No, so input-output tables are used for various purposes, and I think basically for economic analysis, and they are very important in order, for example, to assemble other types of models, not only input-output, but maybe you have heard about other family of models that are called computable general equilibrium models that inform policy. So these tables are at the core of those models that are used by government, that are used by businesses, by several other economic agents. So it's not only in academia that we use them. Now, in terms of calculating the emissions, right, in order to produce these multi-regional input-output tables that we use for calculating the carbon footprint, yes, they have been mainly used in academia so far, but now we have been seeing how they are increasingly being used in order to inform policy. And also, we have been seeing that there is a lot of interest from the industries and companies in order to facilitate their estimation of carbon footprints.
Yeah, absolutely.
And so let's focus on data now. So we are curious to know how you collect the required data, the necessary data, to actually develop those tables and models. And what are the data sources that you use frequently? Are they different among models or not?
Well, as I said, the input-output tables are produced by individual countries, and they are published by their respective offices of national statistics. So that's the primary source for these tables. So they are put together by the governments, and then they publish them, right? So and it's the same thing with their emissions. So these are the emissions that each of these countries are reporting, right, to either the United Nations Framework Convention of Climate Change, or they just report them nationally, or maybe to the World Bank or to some other organization. But those are that's the basic source of information, right? So as academics, when we are putting them together, we rely on the existing databases that are available already. Now, in order to assemble a lot of these tables, and in order to produce time series of tables, because some of the databases that I was talking about, they already have made available tables for a specific period from, as I said, from 1990 to 2014, or different time periods. So now the estimation of those annual tables has been done using a specific procedure, which in each case, in the case of each database, might differ, right?
Okay.
And they are using different assumptions. Now, I think it would take a lot of time to explain what are the different assumptions that are used in each of these databases. But generally, the main source of information are the national governments.
Okay.
Perfect.
Yeah. Maybe we can, if someone is interested, we could provide a link afterwards.
Yeah, we can provide the links to each of these databases. So again, these are the most commonly used, and they are publicly available. So you can just visit the website. I think you can register and then download the data.
Yeah. Yeah, you said that in these different examples of input-output tables you mentioned, you said that they all contain different regionalization. So the number of regions is differs from model to model. And could you give us an idea? Maybe there are some regions that in generally are represented better than the others in those
Yes.
models?
So I would say that the data for the so-called developed world, the so-called global north, is better represented because we have more data for each of the years, right, that are represented. There are countries, as I said, that might publish input-output tables every 10 years, so that makes difficult to estimate annual tables based on a single year, right? Maybe we got one for 2010 and then another one for 2020, and there has been a procedure that was used to estimate all the annual data between those 10 years. So in that case, we have a lot of uncertainty. We don't know exactly what happened there. It has been just maybe a series of assumptions that were adopted in order to create those annual tables. This mostly happens in the developing world and mostly in countries that, as I said, do not produce these tables annually. And also in relation to the so-called rest of the world regions. So in the case of GTAP, we have one rest of the world region that might comprise 120 countries. In the case of ExIOBase, for example, there are 5 rest of the world regions, maybe just separated by geography. So in those cases, we also are assuming that there is a lot of uncertainty. So obviously, the countries where we have more that we have more certainty about the data are those countries that publish their input-output tables on a regular basis. Like, for example, in the case of the UK, the Office of National Statistics already produces these tables annually. So we just take them and insert them into the database, right? So we know that there is, as always, because these are macroeconomic indicators, there is certain uncertainty, but we know that this data is consistent for this particular country, right? The same for other European countries or the United States.
So we talk about global representation here, right? But what's the added value of those spend-based emission factors when we're talking about environmental assessment? And what's the uncertainty around those emission factors? And the other question is that can we still use this data, like spend-based data, for SMEs carbon footprint measurements or not? What do you think?
For companies, right?
Okay, so let me split the question. So the first question I think was, what is the value added of this estimation of spend-based emissions? What do you mean by value added? So what else they can offer apart from only?
Yes, I mean in terms of measuring carbon footprint and in terms of environmental assessment, and especially for like small size businesses and enterprises.
Yeah, because so far we talked about national scale, so it's very like coarse resolution. And when we look at the companies that are using this spend-based emission factors derived from these models of this coarse resolution, what are the uncertainties? Are those spend-based emission factors still useful to assess or understand the emissions in the supply chain?
Okay.
Yeah, top-down versus bottom-up approach.
Yeah.
Okay, so this is a top-down approach, and normally the resolution that you have is not so good because you, at the most, I think you can have something like 60 economic sectors, but maybe no more than that, right? So I think that, for example, if we focus on retail, we only have one sector that is called retail, and we don't have any more descriptions about what is happening within that particular sector, right? However, we know that these emissions factors are still useful, right, in order to get a glimpse of what could be the responsibility or the emissions that are associated with a single company, or in this case, for example, a small and medium enterprise that is within that retail sector, right? because it would give an idea or a representation of the emissions that could be associated to that particular activity along the supply chain. So let's say that I own small and medium enterprise in retail, right? I can use those emission factors in order to calculate to what extent I am generating emissions according to my spend, right?
Yeah.
I know that these are not going to be exactly the emissions. That's not going to be specific to my company, but it gives me a certain idea of the emissions that I am responsible for or that I am generating along the supply chain. So we have to be careful here because these emissions factors are derived from this big picture, right? This big picture that I was talking about. So it is very difficult to have a particular glimpse. Now, if you really want to know what is your particular carbon footprint, then you have to obviously calculate it from the bottom up, right? So you have to look at what are your inputs as a company, what is the energy that you are using, and then look at the product and the life cycle of the products that you are offering. But if you would want to have an easy way to calculate your footprint, right, by using these emissions factors, then you can just calculate them according to the spend, according to your spend. I don't know. Was I what do you think I answered the question or
Yes. Yeah.
Okay.
There are some uncertainties to bear in mind.
Yeah, there are a lot of uncertainties to bear in mind.
Yeah. Exactly. Right. So maybe we tackle a couple of questions from the chat.
Yes, definitely.
Great.
Okay, so Gustav
is
saying, what are some of the advantages and disadvantages of using MRIO tables and spend-based carbon accounting? Okay, the advantage is that, as I said, you can get a very good idea about the carbon footprint that a specific sector is responsible for, right? Because that's because it gives you, in the case of MRO models, it gives you can allocate the emissions according to the spend of all the different sectors, right? So, for example, you can know that a specific sector is responsible for this amount of emissions, or a specific country's amount is responsible for this amount. Normally, the data has already been compiled, and we have a number of models that are available. It's in a certain way, it's not that complicated to use them, right? And they have already been, and the emissions or the carbon footprints that are related to MRIO have already been published. So, for example, the UK publishes its consumption-based emissions or carbon footprint also regularly on an annual basis. You can also find this consumption-based emissions in OECD countries, right? Published by the OECD, and more countries are now publishing these carbon footprints or consumption-based emissions. Now, the disadvantages are that obviously this is a top-down approach, so it might work. It works very well at a global scale or a country scale or an industry scale or sectoral scale, but obviously it doesn't give you the detail that you require for individual companies. Or if you want to go and look, for example, at the carbon footprint of a specific product, right? Another of the big limitations, as I said, is the uncertainty. So in some countries, you know that you're dealing with national statistics, but in other cases, you know that the data was manipulated and sometimes not very transparently, so you don't know exactly what are you looking at. And sometimes there is a lot of uncertainty related to it, no?
Yeah.
Cool. Last question.
Okay, so how to connect IO tables to life cycle assessment? So there have been a lot of efforts in order to bring two families or two ways of calculating the footprint together. So a bottom-up approach with a top-down approach, right? So in this case, the life cycle will be a bottom-up approach. You start by calculating the footprint of products, then you aggregate the products together, right? And then you get the emissions for a sector or an industry, and then you aggregate, you go like that. So I know of a couple of efforts in order to bring together these two approaches in order to calculate something that is called like an environmental input-output with a life cycle assessment integrated. So that's something that I think is also increasing in interest. Like there has been, and I know of two efforts, but I know that more people are doing it. At the moment, I am involved in a project here in the UK looking at the emissions from the National Health Service, from the NHS. And the NHS has been developing a life cycle approach, a bottom-up approach, and they are complementing it now with an input-output approach, which I am providing. So basically trying to reconcile a bottom-up and a top-down.
Top-down. Yeah, that sounds super exciting.
Yeah, so these are kind of the pathways, future pathways for research, the things that are going on at the moment.
That was actually our last question too, about the outlook and the future
Exactly.
research direction regarding this. It seems that one is spend-based and LCA.
Yeah, sounds great.
Yeah,
maybe
are there
just
any questions?
Yeah, I think I have last final question.
Yes.
What do you think, Marco? How can we bring academia and industry to work closer together when it comes to greenhouse gases accounting?
Well, I think that we really need to do that. I think that for a long time in academia, we have been working maybe just looking at how to assemble all these databases, looking at all these academic questions about to what extent countries are responsible for emissions. But I think that it is really important to start looking now at individual agents and companies and households, and because at the end it is the individuals who are going to be putting in place actions in order to reduce our emissions, right? So I think that there are a lot of opportunities now to see how we can reconcile this top-down approach with other approaches and make all this data available to companies and to, for example, small and medium enterprises, and see how we can tailor this data for them in order for them so that they can use it and that they can also calculate their emissions based on that, right?
Yeah.
So it would be really, really exciting to work now with companies and see how we can bring all this information. And I think in this sense, Climatic is doing a fabulous job, like putting together all these databases and making them available to different people and different companies.
Yes, we also advocated this idea that academia and industry should work very close together in order to tackle the global issues. Thank you very much, Marco.
Oh, thank you very much for inviting me. I hope that I was able to provide answers to all your questions. Yeah, and as always, it is a pleasure to be with you.
Great, it's a pleasure.
Thank you so much, Marco.
Thank you very much. Okay, thank you very much to everyone, and see you soon live.
Thank you.
Bye.
Okay, bye. Have a nice day.